Okay, so in this video I'm working through the homework from today, or the classwork from today, Wednesday the 18th of March. It's the solutions to 2014 paper 1 question 2, the question on complex numbers. So welcome back, I hope you got on okay. Here's the question as it's laid out. What we're told is let z1 equal 5 minus I, so that's one of our complex numbers, 5 minus I. And z2 equals 4 plus 3i, that's our other complex number, and this bit here is just the jargon to make the question make sense. So they're reminding you that I squared equals minus 1. Find z1 minus z2. So z1 is 5 minus I minus z2, 4 plus 3i. I'm putting them in brackets so that I can take care to deal with the signs properly. So 5 minus I is z1 minus, in brackets, 4 plus 3i. 5 minus 4 is 1, minus I, minus plus 3i is minus 4i. So my answer is 1 minus 4i. Let's just do that again. 5 minus I, minus 4 plus 3i. So that will be 5 minus I, minus 4, minus 3i. So 1 minus 4i. And remember, that's your real, and that's imaginary. Verify, so show that it's true, that the modulus of z1 minus z2 is equal to the modulus of z2 minus z1. Now remember, the modulus of a plus bi is the square root of a squared plus b squared. So anytime you see modulus, you've got to make sure that you know that that's what it means. It means find the square root of the number, the real number, plus the number in front of the I. That's what a and b are. And you square the real number and square the number in front of the I. So modulus of z1 minus z2 is going to be the modulus of 1 minus 4i, because that's what we just found in part 1. So that's going to be the square root of 1 squared plus minus 4 squared, which is the square root of 1 plus 16, which is the square root of 17. Remember, minus 4 squared is plus 16. Now I've also got to find z2 minus z1, the modulus of that. So first of all, I'm going to find z2 minus z1, which is 4 plus 3i minus 5 minus I. So 4 plus 3i minus 5 plus I, very careful there, which is minus 1 plus 4i. So the modulus of z2 minus z1 is equal to the modulus of minus 1 plus 4i, which is the square root of minus 1 squared plus 4 squared, which is the square root of 1 plus 16, which is root 17. So I've shown that to be true. I've verified that. Give a reason why z minus this w is equal to w minus z will always be true for any complex number z and w. Well, z minus w and w minus z. So you've got two complex numbers, and what we're saying is that when you subtract them, doesn't matter which way around they are, that the modulus will be the same. So we'll just pause here for a moment. So this is a strange question. It's kind of thrown in there in the middle. Give a reason why z minus w equals w minus z will always be true. Now notice these are the modulus lines again. These are modulus. And modulus, if you remember, refers to the distance from the origin of a complex number. Now what we'll have found, if we explored this a bit further, we might do it when we get back to school, is that if you have a complex number, let's take the one here, 1 minus 4i, it's somewhere here. Let's say this is z2, sorry, 1 minus 4i, and this is the complex number 1, we'll always have z, that's 1 minus 4i, and the other one is minus 1 plus 4i, which is up here, minus 1 plus 4i. So one of those we had here, minus 1 plus 4i, which is that one, and 1 minus 4i, which was this one. If you notice, they're actually the image of each other on reflection in the origin. So they are the same distance from the origin, 0, 0, as they are the image of each other on reflection in the origin. So distance is the same. You can also say that the absolute value, so in other words, if you have two complex numbers, we have -1 plus 4i and 1 minus 4i, the absolute value of this number and this number, in other words, ignoring the sign, the absolute value is the same, and the absolute value of the -4 and the 4 is the same. But I think that's a harder thing for you to understand. So just think of it as the same distance from the origin. Now, moving on here, find a complex number z3 such that z1 is equal to z2 over z3. So this is a bit weird because z3 is suddenly introduced and it almost looks like there is an equation to solve, but actually let's explore this a bit more. So z1 is equal to z2 over z3. Now let's just move Yoda down to help us. Let's just think about this for a minute. Say I told you that A was equal to B over C. What I could do is I could multiply both sides by C, and I'd get AC is equal to B. And then what I could say would be that C is equal to, dividing both sides by A, C is equal to B over A. Or what you could do is you could just say A is equal to B over C. You could just swap these two, so that we have C is equal to B over A. And in a way, that's what we need to do here. We know Z1 is equal to Z2 over Z3, but we want to find Z3. So actually, we want Z3 to be up in this place and Z1 to be down here. So we can just switch them. Z3 is equal to Z2 over Z1. Z3 is equal to Z2 over Z1. So Z3 is equal to Z2 over Z1. Sorry, Yoda, I'm going to run out of space here, so you're going to have to go off. So that equals to Z2, which is 4 plus 3i, over Z1, which is 5 minus I. If you remember, for dividing complex numbers, what we do is we multiply above and below by the conjugate of the bottom. So we call this the top, this the bottom, and the conjugate of the bottom is 5 plus I. So I'm going to multiply above and below by 5 plus I. So this is top and this is bottom. So I'm going to do top by top will equal 4 plus 3i by 5 plus I, which is 4 by 5 is 20. 4 by I is 4i. 3i by 5 is 15i. And 3i by I is plus 3i squared. So 20 plus 19i minus 3, because 3i squared is minus 3, which is equal to 17 plus 19i. And then I do the bottom by the bottom. So bottom by bottom is 5 minus I by 5 plus I, which is equal to 5 by 5 is 25. 5 plus I is plus 5i. Minus I by 5 is minus 5i. Minus I by I is minus I squared. So 25, these cancel out, plus 1, which is 26. So my answer, don't forget to pull those together, will be top over bottom, which is equal to 17 plus 19i over 26, which is 17 over 26 plus 19i over 26, and that equals Z3, because Z3 is the answer. Z3 is going to be equal to that. Okay, I hope that works. Bye.